Hi, this is Dr. John Bergdorf. In this video, we're going to explore an example of problem solving. Problem solving in mathematics generally applies to solving a problem that is unique, that you haven't seen before, and doesn't necessarily fit into a set formula or algorithm that you already know. Something where you have to find a solution on your own. This particular example that I want to show you here comes from Karl Friedrich Gauss, one of the most famous mathematicians of all time, who lived from 1777 to 1855. He produced many important mathematical theorems and concepts that are still incredibly important to this day, especially in the field of abstract algebra. One of my colleagues when I was in graduate school said that his life ambition was to do enough mathematics over the course of his entire life to save the next Karl Friedrich Gauss 5 minutes of research time. That's how brilliant he is. Now, like nearly all brilliant people, his intelligence showed up when he was a child in elementary school. This is not a picture of him in elementary school, by the way. And like very smart kids often are in school, a little bit bored with the pace that the other kids were going at, and sometimes got himself into a little bit of trouble. So at some point in elementary school, his teacher came up with a problem for him to work on his own, thinking that it would keep him busy for a long time and therefore out of trouble. The problem for the teacher was Karl Friedrich Gauss answered the question in just a matter of a couple minutes. Here's the question that she asked. Add up the natural numbers from 1 through 100. The natural numbers are simply the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth, all the way up, in his case, all the way up to 100 is what she assigned him. He was able to answer that very quickly. And he used some techniques from algebra to do so, and that's what I want to show you as just a possible idea that you can have. So he made up a variable. Let's suppose that the letter S is equal to that sum of those 100 natural numbers from 1 to 100. 1 plus 2 plus 3 plus 4 plus so on and so on and so on up to 97, 98, 99, and 100. So he's trying to solve for S, in other words. Now here was his idea. Let's take S and rewrite it in a different way. What if I arrange the numbers from, instead of smallest to largest, largest to smallest? 100 plus 99 plus 98 plus 97, and so on and so on and so on, until you get to 4 plus 3 plus 2 plus 1. That sum should be exactly the same. It's the same numbers. Here's what he realized. Let's suppose that we take these two expressions for S and add them together. S plus S would give me 2S. And look at what happens if I basically add straight down the columns of numbers as I go. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. And you see that as you go down this list, whenever you add from in order, smallest to largest, largest to smallest, add the corresponding numbers, you get 101 over and over and over again. And you can even see it down here, 97 plus 4, again, that's 101. 98 plus 3, again, 101, 101, 101. How many times did that give us 101? Well, we're adding up the numbers from 1 through 100, so that's a collection of 100 numbers. So 2S is 101 times 100. That simply then, after this very creative way to set up an equation, gives you a very simple algebraic equation that's no problem to solve at all. Let's just use what we know from algebra. So first of all, 101 times 100 would be 10,100. And then to solve for s, we can certainly simply use the technique of dividing both sides by 2. Whatever you do to one side of the equation, as long as you do the exact same thing on the other side, the solution will not change. And that would give me 5,050. So when Gauss's teacher gave him this question, within a couple minutes he very proudly announced that the sum of the natural numbers from 1 through 100 would be 5,050, and the teacher was amazed and now had to find something else for him to do.